Hi everyone, welcome to the What's New with Amazon ElastiCache for Redis webinar. My name's Damon LaKyle, and I'm an ElastiCache Solutions Architect here at Amazon Web Services. I'm really excited to tell you about the big new features in Amazon ElastiCache for Redis version 6, and I hope you're excited to hear about them too. We're going to be talking about two very important topics today and how Amazon ElastiCache for Redis is improving both of those. The first is better access control to Amazon ElastiCache with roles. We'll walk through why it's important, how you can use it, and I'll show you an example of how it works. The second big item for today is improved application performance with the new server-assisted client-side caching that ElastiCache for Redis version 6 provides. We'll talk about the two primary methods of leveraging it and how they compare. Then we'll see a demo of the client-side caching in action. And I wouldn't leave you without some guidance in how you can upgrade your existing ElastiCache for Redis clusters to make use of these new features. Okay, first up is access control. If you're already familiar with Amazon ElastiCache, you already know there are several options that allow you to control access to the service. Things like encryption, which is part of Amazon ElastiCache itself, and your ElastiCache nodes are in your Amazon Virtual Private Cloud, or VPC. The VPC also provides its own security features on top of ElastiCache features, such as security groups that control ingress and egress rules. And by default, we don't expose your ElastiCache clusters to the internet, so we take security very seriously. With ElastiCache for Redis version 6, we are introducing both users and user groups. Implementing individual user accounts increases access control, while user groups actually simplify the management of those user accounts across multiple clusters. So we'll first talk about authentication and why it's important. So authentication is that process where some entity identifies themselves and then proves that it's them with a password or some other mechanism. It's like me saying, I'm Damon and here's my ID. It doesn't authorize what I can actually do yet, but it does identify me and it proves I am who I say I am. So before ElastiCache for Redis version 6 was released, all Redis implementations had two options when it came to authentication. The first option was to connect to your cluster without any authentication enabled. Of course, we would never recommend that, but some customers prefer that configuration for their personal development environments. The second option was to use a default user with a standard auth token, which can be thought of really as a password. So when a client accesses a Redis cluster and successfully authenticates with that auth token, it has full access to all data within the cluster. But now with ElastiCache for Redis version 6, access control is here and it's flexible, and that is what makes it really powerful. So now with ElastiCache for Redis version 6, you have the ability to create user accounts where each user account has its own password. This means you can create an account that is just for a specific caching purpose, or you could create one for the marketing team, or one that is responsible for updating real-time analytics information. The point here is that when you provide credentials to authenticate with Redis, it no longer has to be shared with anyone else. It can be specific to a person, a team, or even a role. We'll talk about authorization in just a few minutes, but let's see how the relationship of users, user groups, and clusters really simplifies the management of all of this. So if we take those three users we just created, the read cache, marketing, and analytics users, and we also create a new user group, we'll call it Group A, we can assign specific users to that group. Here we're assigning both the read cache and marketing users to this user group. Next we create user group B. And you can see here we're adding that same marketing account to user group B, even though it's already in user group A as well. And we'll also add the analytics account into user group B as well. Now, when we create or modify an ElastiCache for Redis cluster that supports access control, which means it must be running Redis version 6 or newer, then we have the option to assign a user group to that cluster. So here we're assigning user group A, which contains the read cache and marketing users, to clusters 1 and 2. When we do this, it will create those users on that cluster, and you can use those user accounts to connect to any node in the cluster as well. You can probably start to see how this is going to simplify management of user accounts across your clusters. Now let's assign user group B to cluster number 3. So we see that a user group can be applied to one cluster or to multiple clusters. We can also tell that one user account can be created in multiple clusters even if the same user group is not. simply by including the user account in different user groups. So let's say that we have to change the password for the marketing user account. Well, first, ElastiCache for Redis version 6 has a really cool feature that allows your users to optionally have two passwords that are active at the same time. And this is so we can rotate passwords without causing connection problems. You can then remove the original password once you've determined that the application or users have transitioned to the new password. Now, through the relationship of users to user groups, and then from user groups to clusters, if we change the password of a user, or we even can delete a user in this case, that change then applies to the clusters that user account is located. You don't have to change the password on each node or in each cluster, or delete that user everywhere, or create the user, so on and so forth. And this user group relationship is a feature that the Amazon ElastiCache team built for our customers for their Redis deployments. And of course, this is just one of many, many features that we provide beyond open source. Okay, we know that we can create users, and they are in turn created on our ElastiCache for Redis clusters, and we can manage that relationship through user groups. But how do we tell ElastiCache what each of these users can do? Let's start with that read cache user. So we want this user to only run the Redis get command, which simply reads a string object, and that's all it does. We don't want this user account to run any command except get. We also only want this user to access cache keys, and we do that by pattern matching key names, which I'll show you next. Now we need to define the specific access string for the read cache user. The access string is something we provide to ElastiCache that controls three things. The first is if the user is enabled or not, and if we are going to allow them to log in. The second is what commands this user can run, and the third is what keys they can access. This is a string you'll provide in the ElastiCache console, the AWS CLI, or even the ElastiCache API. In this example for our read cache user, the first argument is on, and that means the user account is enabled. If we modify an existing user and use the value off instead, that means existing connections will be maintained, but new connections for this user will not be allowed to connect. This is different than, let's say, you removed a user from a user group. Now, in that scenario, any existing connections they have to that cluster are going to be terminated, in addition to that account being removed. The next field in this example shows the key space that the user is authorized to access. Here we're limiting key access to any key that begins with cached : So, if a key begins with that pattern, this account will have access to it, but we still haven't defined what can be done to those keys yet. Next, we're explicitly saying that to begin with, we want to remove all commands from this user. When we list commands in the access string, a minus means deny and a plus means allow. The @all keyword is an alias for all commands, so we don't have to specify all the commands here. There are also categories of commands that you can use here too, which I'll show you in a moment. And finally, after we've explicitly said no commands are allowed, we then add back in the ability to run the Redis get command. So we can see this user is enabled, has no authority to run any command except get, and then only on the keys that start with cache : Let's look at a different example here. Now we have our marketing user. And marketing doesn't really need to be limited to the commands that they run, as long as it's only on the keys associated with marketing. So we enable the user with the on command. We explicitly add all commands to the user, so they can of course run get, but also set or list commands, hash commands, so on and so forth. And here you can see we're actually using two different patterns to match for. One for MKTG and one for marketing. So you can have multiple pattern matches in the access string. Finally, let's set up our analytics user. We want this user to have access to all read-only type commands. So regardless of the data type, this user should be able to see the value of a key. We also want this user to be able to run those read-only commands against any key in the database, not just a specific subset. You can see this access string is very simple. We enable it with the on keyword. We pattern match against everything by simply providing an asterisk after the tilde symbol. And you see something interesting here. We aren't providing either a minus @all or a plus @all. We're just providing a plus @read. Two things here. The first thing is if you are only adding commands in the string, then a minus @all will automatically be inserted for you, because if you're saying you want this user to have those commands, that also means you don't want them to have others. So if we go back to this user later, we're going to see in their access string that a -@all has been added before all the other commands. The second thing here is that this @read is an alias to all read-only type commands within Redis. So, for instance, this alias specifically includes over 70 different commands, ranging from inspecting geohashes to viewing the TTL on a key, or even ensuring a member is part of a set. So clearly we have a ton of flexibility here with access control. Now let's see how things behave with a few of these users. We're going to use the Redis CLI utility and connect as the marketing user we created earlier. Here I'm using the Redis 6 version of the Redis CLI, and I type in my password. I then set a key named marketing:(A) to the value of 1. And since I have permission to run any command on the pattern of mktg, it lets me set the value, and now I'm going to fetch that value with the get command. All right, worked great. Now I want to fetch another value called cached:(A). And that gives us an error because remember, we restricted the key space to anything with mktg or marketing, and this begins with cached. I highlighted the section of this error message because it's going to be different than the next example. Here we're connecting with the read cache user, and we're going to type in our password. So we use the get command to fetch the key that the marketing user just failed at. All right, worked good. Got a successful response because we are authorized for that key space. Now let's set that same key to a different value with the set command. And here we get an error because the read cache user is not allowed to use the set command. So the first example, we see an error based on the key space attempting to be accessed, and on the second, we get an error based on a command trying to be accessed. So I hope you're starting to see how much control you are now going to have with Amazon ElastiCache for Redis. Now, in addition to these new controls, our new release also contains some additional metrics that are emitted to Amazon CloudWatch, and that's going to help monitor authentication and authorization failures. These are divided into 3 categories. The first is authentication failures, which can occur when a user attempts to log in without the appropriate credentials. The second is key authorization failures, like you saw a minute ago. It's when a user attempts to access keys without the appropriate permission. And we also have a command authorization failures metric, again as you saw a minute ago, where a user attempted to run a command without authorization. You can view them in a number of different ways, whichever is best for you. Now you not only have better control over access to your ElastiCache for Redis clusters, you can also view metrics related to that access. And since you're using Amazon CloudWatch for these metrics, that means you can set up notifications. You can see here I'm in CloudWatch, and in the lower right I could click those alarm bell icons, and I could configure an alarm based on those metrics. I can set up an alarm that triggers after just maybe a single attempt of running a command that maybe a user isn't authorized for, like in this example, and then it appears in CloudWatch. I can set up simple notification service so that I can be notified of it as well. Like in this example, you can see an email that was triggered from the alarm on the previous screen. It's giving me some details as to the status of the alarm, the name of the alarm, when the alarm was triggered, and on which node. But what I don't see here are the details of the command itself. So to get more information, I can go into ElastiCache for Redis and run the ACL LOG command to find out more. And here I've highlighted a few lines of the output, and you can see this cache user tried to run the set command, and they were connected from IP address 172.31.43.79. Okay, so we've covered a lot already, from how to set up a user, to defining their access string, assigning them to a user group, then assigning users to clusters. We can monitor the metrics associated with this improved access control, and we can even be alerted based on the different metrics and situations. I'd like you to think of this as part of your security toolkit for ElastiCache for Redis. You don't have to implement it as I've done here, but I hope this overview of the new access control features have given you some ideas on how to improve access control in your ElastiCache for Redis clusters. The other big topic today is client-side caching. And this topic might seem foreign to some people because after all, you might be using ElastiCache as a cache for one or more services, and that will improve the latency and throughput of your queries. If you've implemented ElastiCache already, what's client-side caching and why should you even want to use it? Really, it's all about latency. We already know that ElastiCache for Redis can dramatically reduce latency by caching data from other services. And when data is stored in memory, we can access it incredibly fast. But even though that data is stored in memory, it's still sitting somewhere else on the network, away from the application that needs it. And if something is on the network, you can be sure it's going to take at least a few hundred microseconds before you get a response to something. Now, the Redis engine usually has a response time of less than 10 microseconds, and that's very, very fast. So if the Redis engine can respond in less than 10 microseconds, but the network will take hundreds of microseconds to deliver that response, it should be clear that most of the latency involved with Redis workloads is due to the network. The only way to actually avoid the latency caused by the network is to avoid the network itself whenever possible. Makes sense. But we need access to the network for at least a few things. The first is to get the value initially, and after that, we need to know when the value is changed or invalidated, which is the commonly used term. Now with ElastiCache for Redis 6, there is a new feature called server-supported client-side caching. This means that clients can now cache keys in memory on the client to avoid the network as much as possible. So now if they have a key in local memory, they don't need to fetch it from Redis at all, which of course saves a significant amount of time. Plus, these clients don't have to continuously pull Redis for updates or invalidations. Instead, the server will now contact clients and tell them when a key has been invalidated so that the client can then remove it from memory. This new client-side caching is offered in two forms in ElastiCache for Redis: tracking mode and broadcast mode. So in tracking mode, the Redis server tracks the keys that each client has fetched. So as an example, here we have a client who gets the key foo. ElastiCache for Redis is now tracking that that specific client has fetched foo. So from the start, we know there's going to be extra memory usage to perform this feature, right? If we use tracking mode, we're actively prioritizing performance of the client versus available memory on the server. And there's really no way around that if we need to use memory to track this information. Now you do have control of how many keys that ElastiCache tracks overall, and that can be adjusted by setting the tracking table max keys parameter of your cluster's parameter group. So we can see that the value is bar from the server, and now the client knows that it can serve the value of that key to the application rather than going back to Redis, because it knows that until the key is invalidated, it has the correct value. Now let's say another client sets foo to a value of bars. This in turn triggers an invalidation from the server, so it sends a message to all clients that it knows have fetched that key. The clients then delete that key from their local cache, and they'll need to fetch the value again the next time they need it. So there's a lot of flexibility with this key tracking feature, but you also have a bunch of options, like you don't have to necessarily track all keys. You can explicitly opt in and opt out of specific keys with command options. So with tracking mode, the Redis server will notify specific clients to invalidate keys based on the internal tracking table it uses. The other approach that's available is broadcast mode. In broadcast mode, the Redis server is no longer tracking the keys that were fetched by clients. Instead, when a key is changed, the Redis server simply sends out an invalidation message to clients whether or not they requested the key. So in this example, we're going to keep it simple. First, we're starting out with the value of foo being set to bars. Now, let's say a client sends an update to the key named X to the value of 1. But our client doesn't really care about it because it never fetched it in the first place. So it doesn't have it locally, and it just ignores that update. But the next update that comes in sets the value of foo back to bar. Now, since the client is caching this key, when it receives this invalidation message, it removes it from the local memory. So you do have control over which keys that your client wants to be notified of. You can do this with a prefix for a key space so that you can reduce the number of invalidation messages coming into your client. Now, one of the use cases where you might prefer broadcast mode to tracking mode is where you probably would have been tracking most of the keys most of the time anyway. And in that use case, you're going to have roughly the same number of invalidation messages anyway. So broadcast mode would actually avoid using the memory that tracking mode uses, and you'd ultimately end up with more usable memory on your server. Okay, now let's look how client-side caching helps in a live demo. So I've opened up my AWS Cloud9 Development IDE, and I have a command line open at the bottom. Now this Python application does just a few things, but it does them really, really well. This application creates a certain number of keys in Redis and then fetches them. But if the client has cached the keys locally, it's going to avoid going to Redis. Whether it goes to Redis is determined by how large I make the local cache size. So based on the parameters I provide on the command line, we can adjust how many cache keys we use on ElastiCache, how many we are going to cache locally, and what our read to write ratio is going to be. This is going to impact things like invalidations, as we'll see in a minute. So let's just run this first test with 100 keys in Redis, and we're not going to cache anything locally, and it will be purely reads at this point. All right, we can see that we aren't getting any cache hits, of course, because we're not caching anything locally. So everything is going to be a cache miss, which means we're going to go to Redis for all of our requests. And you can see that we're hitting at about 900 microseconds or so. So we're going to rerun this test again with half of the keys cached locally on this client, and we'll see what the impact is. So immediately we're seeing at the bottom of the screen, the average latency dropped about in half. That's because we're getting about a 50% cache hit rate and a 50% cache miss rate. So about half of our requests no longer need to go to the Redis server. Now we'll bump up the number of local cache keys to about 90% instead of 50%. So we'll set the number of keys to 90 now. And we can already see here that the average latency dropped significantly down to about 90 microseconds. Now this isn't completely real world, of course, because it's been nothing but reads and no writes. So what happens when we set it to about 90% reads and maybe 10% writes? We should start seeing invalidations as well when we do this. So we're going to change that and we'll remember that this was running at about 90 microseconds right now. Okay. And now we're seeing some cache invalidations because we're now updating keys in addition to writing them. So Redis in turn is telling our client to invalidate the keys that have been updated. So that increased our latency probably 10 to 20%, and we're back up to about 110 microseconds. And then in our final test, we'll see what it's like if we can cache everything and avoid writes completely. Okay, so now we've dropped to the low single-digit microseconds for the response. In fact, it's moving so fast, I think the screen sharing program might actually be having a hard time tracking the updates here. Now, clearly, this isn't a real-world workload, but it does show you an example of how client-side caching can help to various degrees, oftentimes to a very large degree, when it comes to reducing the average latency from clients. So that's really impressive speed. And now I'm sure some of you are wondering how you can start using this. It's as simple as creating a new ElastiCache for Redis cluster and selecting Redis version 6. If you have an existing cluster and you want to upgrade it, I'll walk you through those steps next, but it's really easy to do. Step 1 is to go into the Amazon ElastiCache console and modify a cluster. On the modification screen, you'll click on the version compatibility dropdown and select version 6.x. Keep in mind that to leverage the new users and user group functionality within Redis 6, your cluster needs to already have encryption in transit enabled. That's a requirement to use passwords in general with ElastiCache for Redis. Also, don't click Modify at this stage yet because you need to change the Authentication section. Once you've selected Redis 6, you're going to see a new option called Access Control option. Make sure that's set to Redis Auth Default User. We need to upgrade the cluster to Redis 6 before we can enable the Access Control Lists option. And now you can click Modify. Once your cluster is finished upgrading to Redis 6, you'll go into your cluster modification screen once again. You can now enable the User Group Access Control List. Once you do, then you can select an appropriate user group to apply to that cluster. And this is assuming, of course, you've already created some users and have populated a user group with those users. And finally, you can now click on Modify. Your clusters will be updated to use role-based access control, and as soon as it's finished modifying, you'll be able to use that authentication and authorization. It's as simple as that. So now I'll take about one more minute of your time to review what we've learned and provide a few resources. You've seen today how you can improve the access controls of your ElastiCache for Redis cluster by using users that have their own passwords, and applying those users to user groups, which are in turn applied to clusters, allows you to simplify management of those users and clusters. You saw some really useful new metrics that are provided to Amazon CloudWatch, so now you can monitor and even be alerted of unusual activity. We saw impressive performance gains by implementing client-side caching, and we saw our average latency drop from about 1 millisecond to just hundreds of microseconds, and then even to single-digit microseconds. And finally, we walked through a quick process of how to upgrade your ElastiCache for Redis clusters so you can start using these new features right away. Now, before you go, I'd like to invite you to visit our Twitch channel at twitch.tv/AWS and watch some of our ElastiCache videos. In fact, this month we had our very first Amazon ElastiCache Day virtual event where we shared about 7 hours worth of content. Our FAQ has a ton of great answers for you about our ElastiCache service. You can visit our blog for content ranging from how to cache Amazon S3 objects in Amazon ElastiCache to how you can best monitor your Amazon ElastiCache for Redis clusters. And our forums are also a great place for customers to visit. You can ask questions, read new announcements, and search for topics that might interest you as well. Okay, so I've been doing a lot of talking, and now I'm going to pause for a minute and see what kind of questions have come through. Okay, that wraps up our webinar. Thank you so much for your time today, and I hope you have an absolutely fantastic day.